The Yellowstone volcano has recently caused quite a stir due to indications of increased seismic activity. The volcano was claimed to be hit by 267 earthquakes in 1 hour, rumbling across plains. Join us as we investigate the science underlying this activity and consider the potential consequences of a volcanic eruption in this stunning natural wonder. Yellowstone National Park is home to the Yellowstone caldera, one of the world's most famous and potentially deadly volcanoes. This supervolcano last erupted roughly 640,000 years ago, but its size and the amount of magma stored beneath its surface make it a considerable hazard. The national park is located in Wyoming, America. Yellowstone has seen multiple lesser eruptions and earthquakes, indicating that the supervolcano is still active. Although experts do not anticipate a cataclysmic eruption anytime soon, they are actively monitoring the area for any potential changes. But Yellowstone was attacked by a swarm of earthquakes on April 17, 2023, with 267 quakes occurring in just 1 hour. The swarm's greatest earthquake had a magnitude of 4.3, which is considered a moderate earthquake. The swarm happened near the Norris Geyser Basin, one of the park's most active geothermal regions. While this is not an unusual event at Yellowstone, experts and the general public were concerned because of the possibility of a volcanic eruption. The swarm occurred within the Yellowstone caldera in an area known as the Sour Creek Resurgent Dome. The Resurgent Dome is a massive raised feature in the caldera's center that is thought to be created by magma flow beneath the surface. This type of earthquake swarm is not uncommon in Yellowstone, which sees hundreds of minor quakes each year. Scientists were concerned about the magnitude and persistence of this specific swarm. Some scientists believe the swarm is a sign of increased activity within the supervolcano, while others say it is merely a normal phenomenon and not cause for concern. The swarm's earthquakes were minor and caused minimal damage, but they were felt by visitors and residents of adjacent communities. Scientists from the U.S. Geological Survey and the University of Utah's seismograph stations collaborated to monitor the activity and assess the dangers. According to the USGS, which is the United States Geological Survey, the earthquake swarm was most likely produced by the movement of fluids beneath the surface, such as water or gas. Because the rocks are moved, this movement can cause tiny earthquakes and relieve pressure in the Earth's crust. While the earthquake swarm did not result in a volcanic eruption, it does serve as a reminder of the possible threats at Yellowstone. Because of its size, location, and history of volcanic activity, the USGS has classified the Yellowstone caldera as a high-threat volcano. If the Yellowstone caldera erupted, it would have disastrous implications for the surrounding areas and could have an impact on the world climate. The eruption could spew massive volumes of ash and gases into the atmosphere, causing extensive crop failures, air travel disruption, and changes in climatic trends. Despite the risks, scientists are still studying the Yellowstone caldera to better understand its behavior and potential consequences. The USGS collaborates closely with local communities and emergency services to establish plans for dealing with volcanic eruptions and other natural disasters. These plans contain evacuation routes, shelters, and communication systems that can aid in the protection of the general people in the event of an emergency. Scientists were concerned about the magnitude and persistence of this specific swarm. Some scientists believe the swarm is a sign of increased activity within the supervolcano, while others say it is merely a normal phenomenon and not cause for concern. So, what does this earthquake swarm mean for Yellowstone and its environs? Well, there are a few options. One possibility is that the swarm is the forerunner to a greater earthquake or perhaps a volcanic eruption. However, as previously said, scientists do not believe a catastrophic eruption is near. Another theory is that the earthquake swarm is a normal phenomenon unrelated to any dramatic changes in the supervolcano. This would imply that there is no cause for alarm and that Yellowstone would continue to function normally. Scientists will continue to closely study Yellowstone for any changes or abnormalities, regardless of what the earthquake swarm indicates. Seismometers, GPS receivers, and satellite photos are part of the park's comprehensive monitoring system. This technology allows scientists to monitor changes in seismic activity, ground deformation, and hydrothermal phenomena in the vicinity. In addition to this monitoring system, the USGS has a team of experts dedicated to researching Yellowstone and its supervolcano. These scientists analyze monitoring system data and do fieldwork to gain a better understanding of the park's geology and potential risks. While there is no immediate cause for concern, scientists must continue to regularly monitor the area to protect the safety of individuals who reside nearby. Now let's look more into Yellowstone National Park. The park in Wyoming is well known for its spectacular fauna. The Yellowstone caldera is another name for the volcano, famous for its geothermal features, which include hot springs, geysers, and mud pots. With an estimated eruption volume of 2,500 cubic kilometers, this eruption is thought to be one of the most explosive in Earth's history. Over the past 2.1 million years, the volcano has seen a long history of volcanic activity, including dozens of smaller eruptions and many caldera-forming eruptions. The caldera is located in Wyoming's northwest corner and stretches into Montana and Idaho. It is home to a varied diversity of flora and animals, including grizzly bears, wolves, bison, and elk, and spans around 2.2 million acres. Yellowstone National Park is situated on the Yellowstone Plateau, which sits on a hotspot in the Earth's mantle. A hotspot is a location within the Earth's interior where magma rises from the mantle to the surface. As the magma approaches the surface, it can cause a volcanic explosion or form a magma chamber, both of which can contribute to future volcanic activity. The movement of tectonic plates also has a role in the Yellowstone earthquake activity. The North American plate, on which the park is located, is moving southwesterly, while the Pacific plate is moving northeasterly. This shift places the Yellowstone Plateau in an area of significant seismic activity with frequent earthquakes. Yellowstone also has a gigantic caldera, or supervolcano, which is a large crater caused by an earlier volcanic explosion. If this supervolcano erupts, it has the potential to do catastrophic destruction, and scientists are actively monitoring the area for any signs of increased activity. Earthquakes occur when energy is suddenly released in the Earth's crust, causing shaking and vibrations. In the case of Yellowstone, earthquakes can be triggered by magma beneath the surface, tectonic plate movement, or the release of built-up stress in the Earth's crust. A variety of variables can contribute to earthquake swarms, such as the one that happened in April 2023. One theory is that they are caused by the flow of magma beneath the surface, which can trigger tiny earthquakes as it moves towards the surface. Another explanation is that they are triggered by changes in stress on faults in the Earth's crust, which can result in a succession of minor earthquakes. Did you know Yellowstone caldera has existed for millions of years? It was formed over millions of years as a result of a succession of volcanic explosions. The first known eruption happened around 2.1 million years ago, and it was followed by a series of lesser eruptions over the next several 100,000 years. The Yellowstone caldera suffered a huge eruption approximately 640,000 years ago, covering most of the surrounding area in ash and debris. This eruption is thought to have been one of the largest in Earth's history, with a substantial impact on global climate. The Yellowstone caldera had a series of lesser eruptions over the millennia that resulted in the development of the current caldera. The caldera has grown to be around 30 miles wide and is currently within the limits of Yellowstone National Park. Despite its extensive history of volcanic activity, the Yellowstone caldera was mostly unknown to the rest of the globe until the early 19th century. The first non-Native Americans to visit the area were a group of explorers led by John Coulter in 1806. However, it was not until the 1860s that the region was thoroughly explored, and its potential as a tourist destination was recognized. An interesting fact is, Yellowstone National Park was founded in 1872 by President Ulysses S. Grant, making it the first national park in the United States and the globe. The park immediately grew in popularity as a tourist destination, receiving thousands of tourists each year. The Yellowstone caldera's potential threats were not properly appreciated until the 20th century. Scientists began investigating the region in the 1920s and 1930s and identified the caldera as a potentially active volcanic system. This place has since been the subject of significant scientific research and monitoring. Seismology, geology, and satellite imagery have all been employed by scientists to study the volcano. It is still an active volcanic system and a major natural hazard today.